For balancing of a redox reaction, we have two methods. One is ion electron method, which you have already read. Now, we are going to understand what is oxidation number method. Ion electron method is done. Now is the time for oxidation number method. So, I'll explain it to you through an example which we have taken out here. We will take the same example so that you can understand easily. Cr2O7 minus 2, we call this as dichromate ion, and we take another ion, that is sulfite ion. If salts are given, just remove the metal ions and take the skeletal structures or ionic reaction. If we have K2Cr2O7, we will take out Cr2O7 minus 2, and let's suppose we have Na2SO3. So, we will remove Na and just get SO3 minus 2. So, this is called a skeletal reaction or the ionic form of the reaction, in which we are taking just that part of the species in which oxidation number is varying. It is most of the times it is the negative ion in which oxidation number is changing. So, just mention the negative ions so that it will make your life easier. Right. Next, you have this converts dichromate into chromium plus 3 and sulfite into sulfate. So, what is the first step in this reaction? First step in this reaction is writing down the oxidation number of species which are said to change their oxidation number. So, in this, chromium has oxidation number of plus 6, and in this you can see if individual atom ion is there, if individual atom is forming the ion, then the charge on the atom or the ion is the oxidation number as well. So, chromium, the oxidation number is plus 3 because it is in plus 3 state. Here sulfate you have to find out, and that comes out to be plus 6. Alright. In this also, what the oxidation number of this will be, you can also figure out that the oxidation number of sulfur out here will be plus 4. How you are finding out? You can assume oxidation state of sulfur equals to X and oxygen as 3. So, 3 into minus 2, 3 into minus 2 equals to minus 2. So, oxidation state is calculated like this. So, X comes out to be 6 minus 2, that is plus 4. That is how we calculate oxidation number. So, in sulfite, sulfur has oxidation number of the state of plus 4. Now, let us see. From dichromate, oxidation is happening to chromium plus 3, and decrease in oxidation number, decrease in oxidation number equals to, in one chromium, oxidation number from plus 6 is going to plus 3. So, total decrease of oxidation number, total decrease. So, total decrease in oxidation number is equals to, in 1, 6 to 3 into, so that in 1 chromium decreases of 3 units. So, into the decrease is in 2 into 3, that is 6 units. And in sulfur, we have to see from plus 4 we are going to plus 6. So, increase in oxidation number, increase in oxidation number. So, total increase, we have to calculate total increase in oxidation number equals to 2 units. So, we have to make decrease and increase equal. So, what we will do, we have to multiply this by 3. So, we multiply this by 3. So, you will get 2 into 3, that is equals to 6. So, decrease in oxidation number equals to increase in oxidation number, and before this you can obviously balance the atoms other than oxygen and hydrogen. Before we move ahead, so chromium is 2, we will have 2 atoms. So, atoms other than chromium, oxygen and hydrogen are balanced, and we have balanced total decrease in oxidation number equals to total increase in oxidation number. These are the steps which were critical. Now, you can balance oxygen by adding water and hydrogen by adding H plus. On both sides, let us check out. First, balance the oxygen atoms. So, oxygen atoms this side are 7 here, and 3 3s are 9. 9 plus 7 is 16 atoms this side, and how many atoms are that side? 3 4s are 12. 3 3s are 9 plus 7, 9 plus 7, 16, and that side you have 12 oxygen atoms. So I think you will agree we will have to add water molecules out here, and what will be the number? How many oxygens are less? 4. So 4 water molecules we will add this side, and now you will have 8H, and you don't have H this side. So what you have to do is add 8H plus this side. Now you have a balanced chemical equation. You have a balanced chemical equation. So balanced redox reaction looks like this: dichromate Cr2O7 minus 2 plus thrice of sulfite ion plus 8H plus. This gives you 2Cr3 plus 3 sulfate ions plus 4 water molecules. So this is it. If you want, you can verify total charges on this side and total charges on that side should be equal, and total atoms of a particular element this side and that side should be equal. If you want, we can check out 2 chromium, 2 chromium, 3 sulfur, 3 sulfur. Oxygen atoms are 7 plus 9, that is 16 atoms this side. You have 3 4s are 12 and 4, 16 oxygen atoms that side. You have hydrogen 8 this side, hydrogen 8 that side. If you want, check the charges: minus 2 and 3 into minus 2 minus 6, minus 6 minus 2 minus 8 plus 8, that is 0, 0 charge on LHS, RHS. 2 into 3, 6 positive, 3 into minus 2, 6 negative, 6 positive, 6 negative, again comes out to be 0, 0 total charge this side, 0 total charge that side. So now we have a balanced reaction, and that is how you can balance a reaction of a redox uh, process through oxidation number method. So this is it for now. Thank you.